So it's always nice when that happens. That's what I want to show you guys a couple things. So let's do this first, just to make sure everybody's really fully aware. Here's the homework sheet. And there's another button down here that I got to work now, this button for the homework sheet. And it just lists all the homework for the whole semester, right? So you can get ahead on the homework. Especially chapter 1. Chapter 1, if you read it a bit, you can get the definitions down, you can try to start doing the homework, right? Get a little bit ahead for once. We all know the worst thing in the math class is to get behind because it kind of builds, right? So we went over this last time, but I just want to show you where it is in Canvas. I put this here because there was a link on the syllabus, but I thought it'd be easier if I just built it right in. So here's the link on the syllabus, but you can see right here, link to the textbook. Just bam. So let me show you. This has all the different ways to access the book. You can view it online. I highly recommend you go ahead and download a PDF if you have the space for it. If you really want a hard copy, you can do so. You don't need a hard copy, but if you want one, you can get a hard copy. I think you can get a decent used one for like $20 or something. Give some money to Jeff Bezos, but you know, let's build another spaceship. You never know what he's doing. So let's try to view this online. And the homework, see how now this is a little bit evil. Has anybody been to this site yet? Trying to view this sucker online? Not yet?
This is like the first time I actually.
Oh, okay. So let me do this again. Make sure everybody's really with me. So if you go to link to the textbook, hit open in a new tab. It's got all the different ways to kind of view it, right? You can even download it on Kindle or iBooks if you really, really want to. You can view it online right here. Go away. And then go to contents. Okay, so everybody with me? And again, you can download the PDF. You can get a hard copy of the book if you'd rather have a hard copy, right? Okay. I really want to make sure if you can't access the homework, we're all screwed. So, okay. The homework is always going to be at the end of the chapter. And here's the part that really is kind of evil. I was really excited when I got this book. Number one, because it's free, and number two, because they had practice and homework, right? So I thought, oh, we'll do some of these in class, and then I'll assign these for homework. But some of the problems here aren't really that great. So I ended up assigning your homework from both of these. So if you just click homework, it starts at number 40 something. 42, see that? That could be a little confusing, correct? So the actual homework will start where it says practice. There's number 1 right there. Bam. And it all talks about this situation. Are you guys with me? So if you download the PDF, same idea. You go to the end of the chapter and you start with the practice section. That's where the homework starts. If you get the hard copy, it's even better. Just flip and go bam. If you view it online, you got to click where it says practice, and that's where the homework starts. So everybody, and again, you know, a little give and take with a free book, right? But what really sucks is when you pay $200 for a book and it's just as complicated, right? Okay. Or they have typos, and a crazy ass expensive book. Okay. Any questions about how to access that? Desperately need to get in there and just start trying some stuff out, right? I think I want to do, let's see, do we know enough yet to do this? What was the one, Jeff? I think it was these. Yes, let's do it. All right. Make sure I don't do your homework for you. Yeah, I guess okay, Jeff, you do that. Okay. Yeah, let's try number 44 here. So your homework is 42, 46, 47. So this whole section is basically the same idea. So let's try out number 44. Just to really make sure you guys understand, this section can get a little weird. Some of the homework, the way they word some of the questions is a little weird, so you just got to ask me, right? So Do these sound familiar? Population, sample, parameter, statistic, variable, data, right? Somebody remind me, what's the difference between parameter and statistic?
One's more of an average, and the other one's more of a sample, kind of.
Well, the word average would show up in both,
Oh.
in a sense.
So one's like.
One describes the population, and the other one describes the sample. And thankfully, the word that starts with a P describes the population, and the word that starts with an S describes the sample. That's almost too nice to believe, right? It's like, come on, math people do that more often. So if I said something like 38% of all statistics students take a lot of Tylenol, would that be a parameter or a statistic? Let me say it again. 38% of all stat students take a lot of Tylenol. Would that be a parameter or a statistic? Parameter, because it's describing the population. One keyword that doesn't have to be there, but if it is there, shit yeah, all, right? If I say all bikers, I'm talking about every freaking, that's the population, yes? Okay. If I say 38% of the 80 selected stat students use Tylenol, that would be a statistic because I'm talking about a sample I took. Is everybody with me? So a parameter and a statistic both say the same thing, just about different groups. So they're both going to be a numerical description of a group. Parameter population, statistics sample. Kick-ass. The reason this section trips people up is they don't realize you have to answer A, B, C, D, E, F for all of these. So they'll have somebody turn it in and they'll say 42 is A and 46 is B. And no, you have to tell me each thing. So read through number 44 there. So number 44. Go with it. Okay. So can somebody kind of reword this in a little more English, right? What is this person interested in knowing? Kind of like everyday speak.
A cardiologist would just say the amount of time it takes their patients to recover from heart attack.
Yeah, and this word we know is the average there, right? So this person wants to know how long on average does it take for patients to recover? All right, that makes sense. Because if her patients take longer on average than the national average, she's like, what the hell am I doing wrong? Or do I just happen to have a lot of patients who are worse off? Are you guys kind of with me? So this is kind of like an introductory analysis. Let me compare my stuff to other well-known averages and see, am I way off, and why the hell am I way off? Yeah.
You know, like cardiologists, they do stuff with blood pressure. Because some people have like skyrocketing blood pressure.
Hell
They
yeah.
want to get to the bottom of what's going on. And there's some people that look really healthy, that eat really healthy, but tend to have high blood pressure. And they want to figure out what's going on.
Exactly. So high blood pressure obviously could be caused by all kinds of things. Some of it could be genetic. Exactly. Okay, good. So let's not get too deep into the biology of this part. But I appreciate it. So, in this problem, what is the population? I love you guys. Let me see. I'll go to you, and then I want anybody else. Yes.
People who have had heart attacks.
Okay, and be more specific. Because real quick, I really want you to understand why I'm going to be so freaking picky. If I said, next door, there are people who have had heart attacks. Can you imagine that in your head? Just imagine, next door, there are people who have had heart attacks, yes? Can you imagine that in your head? How many people do you see in your head right now, roughly? 32, right? Is that the population? No. So there's a couple of words missing. So to really make sure you're saying it's a population, it has to be all. Now, secondly, is it really, and again, I really want you guys to be with me. This seems picky, but I want you to realize why it has to be. Is she interested in all people who have had heart attacks?
Just for patients.
So, all of her patients who have had heart attacks. Bam. That's the population. You guys with me? Do you see how you have to tease it out from that little bit they told you, right? They just told you a little bit, one quick sentence, and you have to tease out what the population is. Okay, maybe. I can tell some of you guys are really excited about this whole thing. Again, just to remind you, chapter 1, a lot of definitions. We're going to get into some math that you can sink your teeth into today, but we've got to finish up these definitions, all right? Okay. By the way, see where it says give examples where appropriate? It's going to come into play right now. What's the sample? Do they reference any sample in what they tell me?
Heart attack patient. The heart attack patient sheet measures.
All right, good. So, what I want from you is a little creativity. Say something like a subset of her, or even better, say like 80 randomly selected patients of hers that have had heart attacks. Are you guys with me? That's an example. We don't know what the sample was. I want you to give me an example of what it could be. Right? And if you wanted to, you could basically always just say, hey, here's the funny thing. I really want you to get this. The population was all of her patients who have had heart attacks, right? Oh yeah, I am writing well today. All right. Sample, the funny thing is, see the word all? Replace it with a number. 80 of her patients who have had that, right? You guys understand? It really is that simple, because again, the population and the sample are both referencing groups in the same way, just the population is referencing everybody and the sample's representing a subset. Or discussing a subset. Okay. Now, the parameter. What's the parameter in this case?
Mean recovery period for all of it.
Yes! I'm sorry. I got it. So, parameter and statistic will be some numerical description of the population or the sample, right? So in this case, they didn't give us a number, but I know whatever it's going to be the mean recovery period of her patients, all of her patients, you guys, who have had heart attacks. So the parameter will be the mean recovery period for all of her patients who have had heart attacks. Heart attacks. Pop. Okay. How you guys doing? This is really exciting, so I appreciate everybody keeping it calm. So what about, so here's what's funny. I really want you to get to see how the population and sample sound exactly the same? Just one thing changed, because they are talking the same way about two different groups. Parameter, statistic. They should sound basically exactly the same, because they're both saying the same thing, just about two different groups. So what would be the statistic? What did we say our sample was in this case? I just made one up. What's my sample? 80 of our patients who have had heart attacks. So what would be the statistic? The mean recovery period for
The aforementioned
80 of our patients. Okay. Do you see what I'm saying? It's that simple. Statistic describes a sample. Parameter describes a population. They should sound the freaking same, except for one little thing, right? Okay, I really want that to make sense. Okay. And this is important because we're going to use these words throughout the semester, so you have to understand right now what the hell they really mean. Does anyone remember how I described to you the variable? Maybe somebody I haven't heard from yet. You guys remember how I described what the variable was? You can look back at your notes if you have them. Well, we're not in algebra anymore, so you can't just say X, Y, or something, right? So what was variable in statistics specifically? It was related to the what? Once I gather a sample, what am I going to do with the people, right? If I had a sample, if I had these 80 people in a room, I'm going to come in the room, I'm going to ask them a question, yes? I'm going to say, how long did it take you to recover? The first guy's going to be like 3 weeks. Second guy, 2 days. Oh my God, right? You guys remember this? The variable is related to the question you ask, and the data is the list of all the answers. I really just want these definitions to flow from what the hell you would do in real life, right? They shouldn't stand on their own. They're just what we do in real life. They're just words we give these things. So here, what would they be asking the sample? Basically gave it away.
Recovery time?
Yeah, how long it took a patient to recover. That's the variable. That's related to the question you would ask. You would come up to a patient and you would say, how long did it take you to recover? So what's the variable? How long it took a patient to recover. Remind me again, real quick. What was the data supposed to be?
Answers.
All the answers, a list of the answers. So the only way to answer this question is to give examples of answers. So I already gave you some. So that's on your paper. You would write F, 2 weeks, 7 days, 14 months, still recovering, whatever. You guys kind of with me?
Yes.
Okay. I really don't want this to be a big problem, but it can be confusing if you just saw this out of nowhere, right? So I want to go through one of those problems. I could just think, okay. Let's see, was there anything else weird? I think everything else is pretty straightforward. Let's try. No, we haven't done that yet. That would be difficult to do. Where were you? Oh, you're here. I don't want to do all that. Okay. So let's get back to where we left off, unless there's any questions.
What was the variable of the problem you were solving?
Oh, what was the variable?
Oh yeah.
Oh.
The data is like just your own, like basically like
3 weeks, 2 months, whatever.
Oh.
So the variable is related to the question you would ask.
Okay.
So what would you ask somebody in that group? How long did it take you to recover?
Okay.
So the variable is how long it takes a patient to recover.
Okay.
I really want that to be, because you can just imagine to yourself, what would I say to these people? That's what I would, oh, that's the variable. What would they tell me? Oh shit, that's the data. Okay, maybe.
Yeah. I'm good.
Okay. Just like that. So, let's keep going with this. I don't know. Is this what you guys expected stats to be? I mean, it kind of makes sense. Statistics is a very concept-heavy class. So it kind of makes sense we start with, here's all the words we're going to use and what the hell they mean. Okay. So, just to remind you where we kind of left off last time, the last thing we did was, well, we had a couple things. We had quantitative and qualitative. Right? These are the two big ways to break data down. And then we had the 4 levels of measurement. Does anyone remember any of those? Nominal. Ordinal. Interval. Ratio. But I just noticed that I've never noticed before, and I've been teaching this for way too many years. I don't
Spell
know.
something
Huh?
out. Is it that they spell something out?
Yeah. Anybody ever seen these old black and white movies, the crime movies, where the guy comes out and says, "It was a cold night. This lady came into my office." Right? Film noir. Anybody ever heard this genre of film noir? Those old movies now, and you're all like, I don't watch old movies, man. Black and white? That's crap. No, come on, this is beautiful. And sorry, so it does spell on. Go on. And does that have anything to do with what you have to know? No, I'm sorry. I do that sometimes. Somebody else, tell me. Nominal reference to what kind of thing? Not numbers. But I appreciate you saying that because a lot of people, I think our brains see nom and they think number. No. Nom, remember the Stephen King thing, the queen de nom? So it just references names. Just names. And nothing else going on with it. It's just names. Ordinal adds something. It says, okay, it's names, but they have to be in a certain, of course, order. So there's an inherent order to the names. So this would be sort of like hair colors. There's no order I have to put hair colors in. Whereas this would be like ranking something or filling out an evaluation. They have to be in order to make sense. If they're not in order, you're like, what's going on? Maybe? So these two are more qualitative. Interval is where what makes sense. Subtraction, because an interval of time, you can have a length. How do you get the length of the interval of time? Subtract. So I really want to connect the name with the idea. So this is where subtraction makes sense. What do I mean by makes sense? So again, this is a horrible example that one semester, but if somebody had a jersey number 28 and somebody else had a jersey number 12, 28 minus 12 is 16, yes? God, I got that right. Does 16 mean anything? No, so jersey numbers are not interval, because sure you can subtract them, but does it make sense? Does it mean something? Did I just create a person just by number 16 just pops it? No, doesn't make any sense. So that's why it is nominal. Jersey numbers are nominal. They're just names. They don't have an order, right? You got the number 72 and somebody else has the number 36. They're not better or worse than you. Yes? Okay. And then, of course, ratio, there were two things. Division makes sense? And there's something else, and we talked about temperature, for example. Zero means what it's supposed to. What is zero supposed to mean? The absence of thing, right? If I said I caught 0 fish, that means that the cooler of fish should be empty. There should be the absence of fish. But if I say it's 0 degrees outside, does that mean we're all dead? No energy? No. It can get colder. Okay, maybe. So 0 means what it should. Namely, the absence of things. So let me give you a couple examples. I have no idea if I actually pointed the camera at this stuff. I did. Neat. All right. So a nice one to start with. What if I said, what do you got, Jeff? The model of a car, or the make of a car, like type of car. Like a Ford Bronco or something. What level of measurement would that be? No, there's no order to it. It's obviously not a number. So you see, you can immediately eliminate these two because they're quantitative. You know it's not these two. It's just a matter of which one of these are they. What if I said the number of cars in a parking lot? Yeah, so you could think, now real quick, I want to make sure that you understand this. If there were 8 cars in the parking lot and the next day there were 6, 8 minus 6 is 2. Does it make physical sense? That means there were 2 more cars the day before, right? Ooh, this is groundbreaking, right? But you can go further, right? If one day there was 8 and the next day is 4, there's 4 more cars, so it seems like it's interval, but you could divide. 8 divided by 4 is 2. There were twice as many cars. So you have to go to the highest level you can. Okay, I like it. Kick ass. Number of cars. So type of car would be nominal. Number of cars would be ratio. Cool. What about oven temperature in Fahrenheit? So it's interval. Because again, real quick, guys. what would you say? All right, imagine like a 60-degree day. You got it? What would be twice as hot? Does it have to be 120 degrees to be twice as hot as a 60-degree day? No, of course not, right? If we had to guess, I'd say like 85 or something or so. You guys are kind of with me? What about a 0-degree day? What's twice as hot as a 0-degree day? Well, if you multiply by 2, is it still 0? Is it twice as hot as itself? Okay, I really want this to make sense. So does 0 mean what it's supposed to? If the temperature in the oven is 0 degrees, does that mean what it's supposed to mean? Does it mean the absence of heat? Be careful of it, right? You guys with me? 0 degrees Fahrenheit, does that mean the absence of heat? No! If you're in Minnesota and the house is abandoned and the door's wide open and the oven's open, it can get freaking below 0 in there, yes? It could lose more heat. So this is interval. Because 0 doesn't mean what it's supposed to. Which actually means division doesn't make sense. Right. Real quick, I love you guys. If it was 0 degrees one day, and then it's 2 degrees the next day, divide those. 2 divided by 0. What does that show? What is 2 divided by 0? Error. Does anyone know what we call that? 2 divided by 0? Alright, stay with me. Let me show you a little side note. Alright, this is going to seem really weird for a second. What is 6 divided by 2?
3.
Holy shit. Why is 6 divided by 2 3? Because 2 times 3 is 6. So 3 is the number defined. I love you guys. I'm looking at your faces. You're like, holy shit. 3 is the number defined in such a way that when you multiply by 2, you get 6. Right? Ooh, again, ground shaking. So, what is 6 divided by 0? It would have to be the number that is defined in such a way that when you multiply by 0, you get 6. Is there any number you can multiply by 0 and get 6? What do you always get when you multiply by 0? So this is why we call this undefined. Because there's no number defined to do what that wants. Does that make sense? You guys have heard that word, undefined, right? Okay. Did you ever know before now why we called it undefined? That's why we call it undefined. There's just no number defined to do that shit. Okay, so that was a side note. But again, that shows you why it's not ratio, because if it went from 0 degrees to 2 degrees, that's an infinite amount more. What the shit? It's not infinitely more hot if it's 2 degrees out. Okay, I'll stop. All right. So you have to get some practice with these things. So on some problems, it'll seem like more than one of these fit. Well, that's because all of them should fit if it's a ratio. You always go to the highest thing it could be. So can I subtract, like I said, the number of cars? Can I subtract them and it makes sense? Yes, but I can do more, so that's why I go to ratio. All right, maybe. Okay. So we're almost done with these definitions, guys. So just a little more definitions. I have a worksheet I want you guys to do, kind of so I can shut up for a while, and then we'll do a little bit more real math stuff today instead of just definitions. Okay. Oh yeah, that's a good one. That's a good eraser. Yeah. All right, it's not gonna get any better, John. So a few more definitions, then I want you to work on this worksheet. So remember when we were talking about sampling? Different ways to get samples? Where like you could do a random number generator, or you could go to different classes throughout the day and get people, right? So we're gonna get a little more specific about the ways you can sample stuff. And there's 4 of these, and then we'll have 2 more things about quantitative data, and that'll be it for the definitions we'll talk about for chapter 1. Okay. At least for a little. So different sample, let me write the sampling techniques. Techniques, there you go, Jeff. So you got the ultimate gold standard of random sampling. And of course, this is the one where, you guys remember, every element, every member of the population has an equal chance to get into the sample. Good Lord. Chip out. Okay. What's kind of funny about these is these other ones are also random if you do them correctly. They're just more to it than just putting names in a hat or something. So let me do this one next. There's this type called systematic. So if I wanted to take a sample of you guys, one way I could do it is to kind of pick somebody at random, and then every third person after that would get into my sample. Every third person, right? That's systematic. If I went and took the air temperature every 10 minutes, that's systematic. So you start to see how it's every nth something. Every eighth person, I ask them a question. Every 5 minutes, I go do this. Right? Every 7 feet, I pick some grass and I put it in my sample. Okay, so systematic makes sense. There's a system to it. Every nth something. Every 5th minute, every 7th person, every second car. Right? Every other day, every whatever. Okay. So you can imagine what the problems are going to look like. You're going to say, this person took a sample this way. What method did they use? That's going to be the kind of homework problem you're going to see. And we got these two. Stratify and cluster. I'm going to put these two up at once because they both are very similar, which really kind of sucks. But I'm going to try to make it make sense which is which. So, let's see. I think most of you guys are not too far removed from high school. Is this correct? High school was, okay, so some of us, well, I'm sure I'm a little more removed from high school, but you guys, of course, remember that there were freshmen, sophomore, junior, seniors in most high schools, yes? Okay. So if you wanted to poll, if you were an administrator at a high school and you want to poll the student body about changing something, and you want to make sure that you get equal representation from all of the groups, you would use one of these, you would really use this guy. So do you see how the population is sort of naturally broken into groups? So stay with me, this gets free. Stratify and cluster. The step one is break the population into groups. So step one on both is the same. Okay. So I don't have to break that population, it already is in groups. But I can have another situation where I break it up like A through J and K through M, and so I can break people up by last name or something, right? I can actually break it up. Here, it's already broken. Stratified. So here we got groups. Freshmen, sophomores, juniors, seniors, right? Freshmen, sophomores, juniors, seniors. Same thing here. Break population in groups, freshmen, juniors, seniors. Okay. Second step for stratified is you take some people from each group. So stratified says, I'm going to take some people from each group. And that's going to be my sample. So the key phrase for stratified is some from all, or each, right? So you have groups, and you take some from each group. So every group would feel like they're represented. So it's sort of like our government, right? What's the House of Representatives made of? Based on population, so it equally represents each state. So if we just randomly chose people from all over the U.S., could there be states that has nobody coming from them? Yes. So to be fair, we broke it into groups, and they would take people from each state to represent, and that's why it's called representative. It's not government class, we're not going to argue about how truly representative it is. We can talk about that elsewhere. Sorry. Has everybody got that? That kind of makes sense, right? You want to make sure everybody's kind of heard, so you break it into the groups, and you take some from each group. Then cluster, the thing cluster does, is it randomly picks some groups, and everybody from those groups goes into the sample. So something, do you guys see what I'm saying? Real quick, a little demonstration right here. See how you guys are all broken up into rows, right? And one of you is like, this is my row. Nobody else get my row. All right. So you guys are broken up into rows. So if I want to do stratified, I would randomly select a person from each row. So are you guys with me? That would be stratified. If I do cluster, I would randomly pick 2 rows maybe and take everybody from those 2 rows. You guys see the difference? Now real quick, let me see what you guys think. Are those 2 methods random sampling? What's it take to be random again?
Oh, no.
Don't stand firm. Right? Everybody, so if you guys are the population, yes? You guys are the population. You with me? If I pick somebody randomly from each row, does everybody have a chance to be in the sample?
Yes.
Okay?
They don't have an equal chance though.
Why not?
Because different rows have different people. Like,
I don't care.
Okay, never mind.
If I randomly select somebody from each row, if you don't think that's random, tell me who in the population did not have a chance to be in the sample. So I randomly select somebody from each row. Is there anybody in this room right now that did not have a chance to be picked? So did everybody have a chance to be picked?
Yes.
So it is random. What if I do the cluster way? And I like cluster because you guys know those silly cereals where they got the honey nut clusters, you know? So I think of cluster as you just got chunks and you take every chunk, right? And some chunks you leave behind. Are you guys with me? Your spoon goes in, you're what am I drinking? So if I take 2 rows and I take all those people, is that random? Does that meet the gold standard?
How would you describe like a sports draft as like random? Like
Well, sports draft, you would agree with me that when they pick somebody, they're not picking them at random. They're biased in their selection, yes? So nothing wrong with that. That's the whole point of it. That's why there's an order to it, right? But you see how it's not random then? Okay. But I like the question. You can argue like the NBA has that whole thing where they do the lottery for where certain people, I can't remember now, it's been a while. Even that's not random because again, when they go to select, they're selecting with a purpose. They're not just sort of going, throw the dart, oh shit. Throw the dart, oh yeah, we got that guy. Right? Okay. So coming back to this. If I randomly select 2 rows and I take everybody from those rows, did that meet the ideal of random sampling? Why do you think no?
Because everyone was selected was random already.
Say, I'm sorry.
Because everyone was selected. If it's random, it shouldn't be. Like, it
Now remember, what's the one thing random sampling needs? There's only one thing it needs. Every member of the population had a chance to be in the sample, right?
Is the gold standard that everyone has to have a chance or an equal chance?
Well, it's an equal chance, which still it means. It is completely random. if I randomly pick 2 rows and I take everybody from this row, can you identify a person that did not have a chance to be in the sample?
This row,
No. See, you're thinking about after the fact. The minute I really want this to make sense. If I have a sample made, you can't go, well, Jerry wasn't in the sample. It's not random. I don't give a shit if Jerry wasn't. Could he have been in the sample? Yes. So before I took it, did everybody have a chance? Yes. Now, if I got some people outside in some row I set up because I don't like them, I'm like, then they don't have a chance to be in the sample. You with me? All right. That'll be real. If I ever do that, report me to somebody. Right? Okay. Are you guys kind of with me? So I really want this to make sense. This will only be your answer to a question if there's no other method to it. If it's like names in a hat, the answer is random, right? There's no other method to it. You with me? But if they break it into groups and they take some people from each group, that's not just random. It's specifically stratified. Yeah, like it? Maybe. This is crazy important. Stay with me. One semester, I taught statistics in 3 weeks in January once. Thankfully, they made it 4 weeks now, so it's still 4 weeks. Can you imagine? Holy shit. And this one guy, I was teaching about this, and this one guy, he was in the Iraq War, and he said, Jeff, cluster is bullshit. I said, that's an interesting claim. What do you mean? So he told me about the situation. I researched it. So here's what happened, guys. So you guys remember some stuff happened in Iraq back in 2001, 2002, and still, So went into Iraq, did some stuff. Later, they wanted to take samples of regions to see how safe the country was. I'm kind of paraphrasing here, but so what they did was they broke the country of Iraq into regions, right? And so that's sounding like one of these 2, right? And then they took everybody from some regions. That sounds like cluster, right? The problem was they weren't military. They were just some statistical analysis firm. And they said, this is way too dangerous. We're not going to pick that one. Right? And then they picked from the other ones randomly. Are you guys with me? Do you guys see the problem?
Yes.
Was there an area that could not have been in the sample? Very obviously, right? Because they just said, we ain't going there. And it's not funny. When I use the word funny, the funny thing was, the whole purpose of the paper was to describe the safety situation. And there were sections, they were like, that's too dangerous, we're not going to go there. Do you guys understand? So I don't blame the student for having major problems with that method. But it was just they applied the method wrong. Yes? If I just said, no, I don't like you guys, so I'm going to pick from the other rows, I mean, that's automatically not random. There are 3 people that didn't have a chance, right? Okay, maybe. You guys are fine, as far as I know. Just want you to know. Okay, all right. You guys feeling okay? Do you guys understand? These are different methods. Sometimes some of them make sense, sometimes some of them don't make sense. So systematic, for example. An assembly line. You with me? There's an assembly line. And let's say, so I always think, I think cartoons when I think assembly line, but let's just imagine there's this thing, it goes ka-chunk, and then it rolls over, and then it goes ka-chunk, and then it turns around, then it ka-chunk, right? You with me? So let's say the third ka-chunker has a defect. So I take a systematic sample from my assembly line to see how good my stuff is, and I take every third one or something. So every one of them is defective. So I'm thinking everything is defective. Are you with me? So systematic doesn't make sense to use in the case where there might be something cyclical like that, something happening every whatever. You want to use a different sample method. In that case, you probably want to use just random. Just let a whole batch be made and then randomly select some, right? I don't know if you guys understand what I'm saying. So there are reasons you'd rather use some over the others in certain situations. Okay. Oh, yes.
I have a question about stratified, because with saying random, everyone needs an equal chance. If you have like a row with 5 people and a row with 1 person, and you're grabbing 1 person from each, the row with 1 person, that person's guaranteed.
Okay, good. So there's something called proportionally stratified.
Yeah.
So that's more like our House of Representatives. Whereas pure stratified is like the Senate. And again, I know this isn't a government class, but you guys understand the main difference between the Senate and the House of Representatives?
Of course.
Anybody have any idea how many people are in the House of Representatives? 435, right? How many people are in the Senate?
It's 100.
100, right? Every state gets 2 senators no matter what. So Wyoming, with the least population, gets 2 senators. California, with, holy shit, they get 2 senators, right? House of Representatives, based on the population. So I love what you're bringing up. There's something called proportional sampling. So like in the freshman, sophomore, blah, blah, blah. Let's say there's 80 freshmen, 1,000 sophomores, blah, 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 right? So maybe you would take 5 freshmen and 20 sophomores, or whatever the right proportion would be. Okay, I love it. I like that you brought that up. I don't have to get that detailed, but there's times where you combine 2 methods. But we're not going to get that deep into it. I just want you to know the basic methods. Okay. 2 more definitions, my God, and then I'll shut up, I promise, for a little bit. Okay. You're having issues. Well, the last 2 definitions of this freaking chapter, okay? Just straight definitions, I'll say that. And this has to do with quantitative data. What was quantitative data again? Number, truly numerical, right? Meaning you can do algebra to them and the answer makes sense. Okay. It could either be continuous or discrete. Let me be really careful here. This is really discussing the variable that this data can come from. So the word continuous is probably a good one to start with, because we kind of know, maybe we know what continuous means. Can somebody give me an idea of what continuous means? I like it.
That keeps going.
Keeps going.
I was gonna say like ongoing or thorough or like rapid.
I love it. So let me make sure you get something. So if I just start counting 1, 2, 3, 4, 5, 6, and I keep going, will I be able to keep going forever? Yes, right? Because I can't ever get to the biggest number, because then you just add 1 to it. That's not continuous though. Continuous means I don't pick up my pen. So for example, on a number line, you have 0, 1, 2, 3, right? Continuous would mean every number between 0 and 3 is possible. Discrete would mean only certain numbers are possible. So for example, if I said how many doors are on your car, and you say 2.8756 doors are on my car. What? What? Do you understand? That's silly. How many kids do you have? 1.7. I am not coming to your house. What the shit? What is this 0.7 kid phasing in and out of reality? I don't know. 70% of the time he's here. No? Yes? You guys understand? So continuous means it's a variable where the answer could be anything within a continuum, within an interval. So if I said, how heavy is your backpack? Could you say, and would it make sense to say, 9.38 pounds? It makes sense, doesn't it? Now, what would you actually say? Because we're humans. We would say about 9 pounds. But what could the answer be? If I put it on a very precise scale, I could get 9.38754 22221 pounds. Couldn't I? It makes complete sense, right? If I say how many books are in your backpack, what kind of answers do I must make sense? What must you give me? Whole numbers, yes? You guys kind of with me? Now, real quick, going back to the car doors. Anybody ever have a truck or something that's got half door? It's officially, you guys ever heard of this? The little, it's a half door, right? Yeah, so you could have like 2.5 doors, believe it or not. Does that make it continuous? No, because you can't have 2.0394 doors. You with me? A little bit? 9% of the time, a door appears. What? What is this? I really want this to make sense. So continuous means the answer to the question could be any number with any number of decimals, and it makes sense. Discrete means I'm expecting a specific type of number. Maybe? Maybe? Okay. So for example, if I said how many, well, that's a little tricky. Well, here's a tricky one. What about the price of gasoline as listed at a gas station? Say again?
It can only be up to like a full cent. You can't have like 3.92, 40.
Yeah. So give me a price of gas right now.
$10.
Holy shit, where did he go? Alright. Let's not go to the same gas station. So what is it, $4.59 or something? I don't know what it is.
Yeah, it is around like 4.59 or like 6 something.
Yeah, and of course you guys notice, what do they do? What do they do right here?
99.
Right. So it's 4.599, so it's really 460. Are you with me? Of course, you ever notice most commercials, come down and I'll sell you a couch for $1,599, because they know psychologically, if they say $1,600, we think it's more expensive than $1,599. So, side note. So, price of gas as listed at a gas station. Why is it not continuous? There are decimals there, aren't there?
Yeah, but it can't go on.
It's not going to keep going forever, is it? They're not going to say 4.59987654 continued at next station. You know, you guys know what I mean? And by the way, real quick thing. There's a what do you call it, Jeff? There's a bowling alley at the bottom of the hill in Fletcher Parkway. You guys know about that? And I don't know if they still do this. On their board, they said you could play an hour of the game for this. Does anyone see something wrong with this?
Yeah, that's 0.99 cents.
I pay 1 penny and I'm like, keep the change. And I get an hour of bowling. So what they meant was this, of course, right? You guys understand the difference? Or they meant this. This is less than a penny. Yes? 0.99. I'm sorry. So that, again, I apologize. I go off on tangents when they come. Okay. So continuous, it could be any number of digits. So if I tell you I live 10 miles from here, what kind of variable was that? Nope. What could it be?
Any number.
Why did I say 10? Because I'm not a freak, or I'm not that big of a freak. I'm a math guy, but I'm not going to say I live 10.076 miles away. Who the shit are you? I live square root of 30 miles away. Get out of here, right? Well, so these are all about what it could be, what it's allowed to be, not what you actually said. But if I said I caught 10 fish, which one? Discrete. Because the guy that said they caught 7.3 fish, you know, I don't know what you're talking about. Okay, all right. So let me shut up finally. I'll let you try this out. Anything. don't normally do, but I'm noticing there's quite a few people out. Mike, Bose? Sabrina? Leslie? Joseph Garcia? Joseph? Jaquel? Did I say that right?
This is Jockwell.
Jockwell, alright, thank you. Satori? I think Satori's out. Davis? Hey. Tyrone? Nicholas, or Nick? Yeah, forgot what you guys are. Edmundo? Hey! Rhiannon? Bryce? Ty? Martha? Sophia? Ryan? Hulula?